So today I'm going to tell you about a programming language that I'm working on. So why exactly am I writing a programming language? Well, first of all, it's because it's fun and you can learn a lot about programming by writing a programming language. But then the second problem that I'm trying to solve is that there really isn't a good programming language that fits my needs and ticks all my boxes. So what it is that I need? I need a language that I can use to write one-off scripts and small programs. Then I need to be able to prototype algorithms. I need to be able to glue things together. And finally, I need to be able to store some data and read it back when I run the program again. This immediately disqualifies existing programming language such as Rust or Go, because Rust and Go require too much ceremony and you need to set up modules, pull up dependencies and things like that. With Python and Ruby, your main problem is that as long as you work on the same interpreter version, everything is fine. But as soon as you try to switch to a different operating system and put a script on a different Linux box, it will stop working. You can write in TypeScript, which is going to be fine, unless you remember that there is a Node.js interpreter you need to carry around or a bun interpreter. And in almost all of those cases, the problem is that you cannot easily compile a simple binary and then ship it to a Linux box that you need to work on. The closest thing that I think is going to work is probably TCL or Lua. Both languages are pretty old and pretty stable, and they really can produce statically linked binaries. But for Lua, the main problem is that it combines arrays and dictionaries, which is very inconvenient. And TCL just uses strings for everything. So it is really the basic data structures that I have problems with. So yeah, I decided to write my own language. So what would be the main idea of the language? Well, I'm going to follow the same concepts that people have invented in TCL, Lua, and some of the Lisps. Mainly, make your language small enough and have few primitive data types. In my case, it would likely be dictionaries, lists, arrays, strings, dates, times, and integers. So those would be the only available types, where you would, if you need a more complex data type, you would just combine those. There would be no object-oriented programming or classes. So instead, you would basically rely on those basic structures. But if you have a limited set of primitives, you can do interesting things, such as you can take any address in memory, a pointer, and you can serialize any data structure into either a binary format or a text format, which would be mutually interchangeable. So using those, you can first easily read and write configuration files, which would basically consist of the same semantics as the core language. They will just not be able to execute instructions. And then the second thing is that you can use the same data structures to read and write binary files. For example, if you need to persist information between the restarts of your program, you can just take an object in memory, serialize it, write it to a file, and then read it back again when it starts. So this is how, for very simple cases where you would need a database, where you don't need a proper database, but you just need to serialize something and store, you would be able to do so. And then the interesting part is also in concurrency. So in many languages you have multi-threading, where the threads can access shared state. In my languages, I'm taking the threading model from Erlang, where your threads have non-intersecting memory, so you cannot point to other threads' data. You can only pass messages, which gives you interesting properties. You can have very easy reasoning about the separate things that are working in your program, while you just do message passing between threads. So again, an interesting property that you can take from this is that you can start threads in multiple different processes, isolated processes, and still exchange the same types of messages that you usually do. So this is what you get if you base everything on simple data structures. Another interesting part about my language is that I'm not going to pursue performance. There are lots of high-performance languages on the market, and you can grab any of them and optimize your program to your heart's desire. You can use them to process large amounts of data, but me personally, I don't care all that much for my personal programs about the speed. So it is better to make the language small and understandable and not have lots of bugs in it, and make it stable. So what I decided that I would do is I would just not do any type of JIT compilation. I would have only just a very simple virtual machine that contains under 100 bytecode instructions, model it loosely after the RISC-V architecture, just with adding a garbage collector on top. And then I would have a simple compiler that would take the program source and turn it into the bytecode for this simple virtual machine. And another thing that I want to do is make this language easily embeddable. So because I have a universal serialization format and you cannot easily point to an object inside a virtual machine, and you instead always have a copy of the object when you call a function from our outside world to the virtual machine. It allows you to easily build bindings, and you don't really care about what type of runtime you have, be it Go, C++, Rust, whatever. Any language would be able to work with this simple virtual machine. If you're wondering, is this just a plan or have I actually made anything of substance? Well, I had. I actually started working on this language in the middle of the summer during a long plane flight. I started writing it in Zig initially because I wanted to learn Zig, and it seems like a very nice low-level language. But then I ended up just rewriting it in C and doing this very, very simple because I needed to get the basic ideas straight. So what I have now, right now I have a repository on SourceHut where I have about, I would say, 4,000 lines of code, which already has the basics of the virtual machine implemented. It has the data serialization, not of everything, but a good chunk of data structures, integer arithmetic, dictionaries, arrays, things like that, and the garbage collector. It is still based on just assembly. I have only the virtual machine and an assembly compiler. And don't let the assembly name fool you. This is not the regular type of assembly as you would find on x86 or ARM or even the RISC-V architectures. This assembly language, even though it's 32-bit instructions, it still has a garbage collector, so you cannot access arbitrary memory locations, only the ones that you explicitly allocated. So yeah, there is code, it works, that there are some tests. And what I suggest to do is just take a look at how it works right now. So what you need to do is you need to check out the code, you need to change the directory to the root of the code, you need to type nix develop. By the way, I'm a big fan of nix, but that's probably a topic of another video. And now you type make. Everything here is based on plain make files, so you don't need anything else fancy. And now we will take a look at a simple example that works with a UTF-8 string. Let's take a look at the utf8.asm file. What it does, it takes a string, loads it into a register, and then it first gets the length of the string and calls the print function with the result, so the string length. And in the second part of the code, it takes the third character, which is actually the fourth because indexes start from 0, extracts it from the string and passes it to the same print function. Pretty easy, right? What is important to note here that it is, as I said before, a garbage collected language, so whenever you put a string to register, you don't actually put the whole string to the register, you put the address. And that address gets tracked by the virtual machine. As soon as you stop referring to it, it will be garbage collected. Now let's try to build the example. What you need to do is you cut the file, pass it to the assembler, and then the assembler will build the file and just produce the bytecode, and then you pass it to the virtual machine. As a result, you get 7 and a smiley face, which is as is expected. So the second part, what we're going to do is that we're going to look at the bytecode. So if you strip out the VM run and pass the result to XXD, which is the way to explore the binaries, you would see that it is actually the binary code. Now, it's interesting to understand what this binary code is. This binary code is actually, as I said before, we have everything being a basic data structure. The binary code of the virtual machine is actually the same data structure, just represented in the binary serialized form. I have a special utility that allows you to decode this form. So let's try to run it. When you run it, you get the 2 arrays. The first array is a set of opcodes. This is what is getting executed by the virtual machine. And the second array contains static variables that these opcodes refer. So if you have constants, for example, these constants will get there. As you can see, there is arguably some progress on the language. Whether big or small, you decide. I quite like it. I work on it almost every day in the evenings, even if writing like 10-20 lines of code. So if you want to get more frequent updates than this YouTube video, probably I will film more about this, but it's hard to film videos, it's easier to write. So if you want to get like updates once or twice a week, you can subscribe to my blog where I write about this particular language most of the time. And yeah, I think I'll tell you more in the next videos. See you, bye-bye.